Students, in this video we are going to see the problem under for the linear algebra, which is tutorial class. So we are going to discuss two type of problem. One from to finding your solutions which you have learned in the consistency with the test of consistency, whether we have to get a unique solution or you have infinite solution or no solutions. So little different problem we are going to discuss today, and along with that we are going to see the one more problem, which is Gauss-Seidel method. So the first question: investigate the value of lambda and mu such that the system of equations x plus y plus z equal to 6, x plus 2y plus 3z equal to 10, x plus 2y plus lambda z equal to mu. Unique solutions: B. Infinite solution. C. No solutions. So before into the solutions, we'll shall clarify what we need to calculate from the question. So the question has been given the system of equation which has been expressed along with the unknown of x, y, z. We have a two more is there, which is lambda and mu. So what we are going to find out, on what value of lambda and mu we shall get a unique solution or infinite solution and no solutions. So all the three cases we are going to discuss in this method. So first what you have to do, whether what type of solutions we are having it, we have to first take it with augmented matrix. From the augmented matrix we are going to find rank of augmented matrix and the rank of A, and based on that which we are having a number of rank will be which is less than of m, less than of greater than of m. So we are going to fix it with a type of solutions. So for that reason, first I am going to write my augmented matrix. What is that? AB is equal to 1, 1, 1, 6, 1, 2, 3, 10, 1, 2, lambda, mu. So which is given from the equation. Just I am written the coefficient matrix of A and the right side value of B has been written it. Okay. Now what you have to do, as usual, the first step, we are going to convert the second row first element and third row first element to 0 by using which row? We have to use in first row, isn't it? So first row you can write as it is 1, 1, 1, 6. And it's coming for second row. What is that? Just I have it 1. So R2 minus R1 I can able to get 0, isn't it? 1 minus 1, 0. 2 minus 1 I'll get 1. 3 minus 1 is 2. 10 minus 6 will be 4. The next one, what is that? Again, it is only 1 is there. I can write it R3 implies old R3 minus R1. So what is that? What is a new R3 I'll get? 1 minus 1 will be 0. 2 minus 1 is 1. And lambda minus 1 is lambda minus 1 as it is, because we couldn't know the value of lambda. The next one, mu minus 6 as it is, mu minus 6. Now, you can see that here in the third row, to convert 0 here, what it is there? I have it 1. So it is like R3, how it is the new R3 will be implies, you are going to take it old R3, just what is it? Minus of, you are supposed to use your second row, right? R3 minus R2. So what will happen? 0, I'll get it, 0 minus 0 will be 0. Then 1 minus 1 will be 0. Lambda minus 1 minus 2, isn't it? So you have here, what is that? Lambda minus 1 is there, and then I have it minus 2. It will become lambda minus 3. And the next one, you have already mu minus 6 is there, and minus of 4, I'll get mu minus 10. Okay. So this is the maximum level we have done it. Now we are going to analyze the solutions. Right. So now you can see that I have it almost we have reached in the echelon form, and to find it, what is it? We have to test the consistency. So before into that, the question is asked for three type of solution. So as per the definition, what is your unique solution? The unique solution is nothing but, what is that? The rank of A and rank of B must be number of unknowns, right? So it is number of unknowns is here 3. So rank of A, rank of AB should be 3, means all the rows should be appeared, right? That means your lambda minus 3 should not be a 0 and mu minus 10 also should not be a 0. Then only I will get 3 non-zero rows, isn't it? So in that cases, the unique solution means we must have the condition rank of A is equal to rank of AB should be equal to 3. So if rank of A will be 3, lambda minus 3 is not equal to 0 since the other two entries in the last row of A are 0 because already you have these two 0, so this should not be equal to 0. And if lambda minus 3 is not equal to 0, so lambda is also not equal to 3, isn't it? So irrespective of the value of mu, so lambda AB will also be 3. Okay. So similar, lambda of AB you can take it, it will also be 3. So we can tell the system will have a unique solution if lambda is not equal to 3. That's it. So it's infinite solution means what is the condition? The rank must be less than of 3, isn't it? Because you have it n value here. That means the rank of A and rank of AB, which is equal to R, should be less than of 3. So less than of 3 means we must have a minimum rank should be 2, isn't it? Because you have in 3 row, the first row and second row are non-zero rows in the cases. Then must be, the last row must be a 0 rows. If it is 0 row, what is the condition? Here rank must be equal to 2. So it's possible only lambda minus 3 equal to 0 and mu minus 10 also should be equal to 0. In that cases, when lambda is equal to 3 and mu is equal to 10, the system will have a infinite solution. Clear? So next one, no solution. When it will be no solution, the rank of A will not be equal to rank of AB, isn't it? So both the rank, whenever it's not equal, then we can tell the system is inconsistent or we don't have a solutions. So for that reason, what we needed, either lambda rank of A must be 3 or rank of AB will be 3. So any one will be 3 and the other one will be 2. So any cases. So we are going to discuss the first case. The rank of A is equal to 3 if lambda is not equal to 3. And we have lambda is equal to 3. We obtain, what is that? Lambda is equal to 3 means we'll get the rank of A is equal to 2, isn't it? So here lambda is equal to 3 means it will go 0. The rank of A, only the A matrix, I can get the rank is 2. Okay. And what is that? You can go with the other cases also. You can tell if it is having this value will be 0, which is you having mu minus 10 is equal to 0 and this is also will be 0. We can conclude it will go for infinite solutions. So no solution is possible only with when A, rank of A is not equal to rank of AB. So that is possible. Rank of A must be equal to 2, rank of AB is equal to 3. Then you can tell it is for inconsistent. That means no solution. Okay. So that's all the 3 conditions we have discussed it. Now we'll go with the next question. Employ Gauss-Seidel iterations method to solve 5x plus 2y plus z equal to 12 and x plus 4y plus 2z equal to 15 and x plus 2y plus 5z equal to 20. Carry out 4 iterations taking the initial approximations to the solution as 103. So what is that? We have seen in the last video, which is Gauss-Seidel method. So the question has not mentioned how many iterations we should do, right? And the initial conditions also has been not given. What we have done, we have default has been taken as an initial condition of x, y, z will be a 0. But here you are supposed to start from x is equal to 1, y is equal to 0 and z equal to 3. And also whether you are getting approximate answers to comparison of your third and fourth. Till the fourth iteration you should do. Okay. So we'll go for the solution. What is the first step? We have to check it is a diagonally dominant. So as per the first question, it is already diagonally dominant. C5 will be greater than of 3. 2 plus 1 is 3. And similar, 4 is greater than of 3. Yeah. And here also 5 is greater than of 3. So diagonally dominated. And what we have to follow? So you have to form equations from the first one. X is equal to 12 minus of 1 by 5 into 12 minus 2y minus z. Similar, you can write y 1 by 4 of 15 minus x minus 2z. And z equal to 1 by 5 of 20 minus x minus 2y. So what you have to do the first iteration? Use the given initial condition and substitute y and z value. Y is equal to 0, z equal to 3. Substitute and you will get your x of 1 as 1.8. So what is your y of 1? Substitute your z value and x of 1 which you got it a recent value. Okay. So y of 1 also I got it 1.8. And what is your z of 1? So z of 1 value you should replace the recent value x of 1 and y of 1, I can get 2.92. So now you can go for a second iteration by using your first iteration's value, and you can do x of 2 substituting. I can get 1.096. You can use the calculator and to get a answer. So y of 2 is, what is that? 2.016, and z of 2, by substituting your x of 2 and y of 2, I can get my z of 2, it is 2.9744. Next you can with a third iteration by using the second iteration value, I can get my x of 3, what is that? 0.99872, and your y of 3 is 2.01312, and z of 3 2.995. Okay, so to do the fourth iteration, this is your last iteration because the question is asked to do only carry out with 4 iteration. So fourth iteration you should use your third iteration value, so which you have in terms of y of 3 and z of 3. Substitute, you will get your x of 4 is 0.995752, and your y of 4 value you have to use x of 4 and z of 3, isn't it? I'll get 2.003562, and z of 4, substitute your x of 4 and y of 4, I'll get 2.9994248. So since the question is asked to do only in 4 iteration, I'm going to write a solution which you got a fourth iteration value of your x4, y4, z4 is your final answer. So x is 0.9958 and y is 2.0036 and z is 2.9994. Okay, so that's all. We have done your conclusions. Okay, so that's all for your Gauss-Seidel problems. Thank you.